So, welcome to the final project of electromechanical robotic systems. This has been a very interesting project because although there were more number of pins available this time, we still had to figure out how the power distribution worked. Uh, there was a lot of troubleshooting with uh, different components not working together or one of the components working and then stopping. Uh, so it was a very interesting project. The project concept was to simulate a rescue vehicle that would go on a particular zone to find any kind of human presence. The DST-11 sensor would help us identify if some temperature rise or humidity is found. The ultrasonic sensor would help identify obstacles in front, and we would have the DC motor running forward to make it go forward and backward to make the vehicle move backward. The servo motor would control the directional change. Um, Although this is all being done by the Arduino, our gesture control using the media pipe landmarker would help us actually control the way in which the direction of the vehicle is changing. So it was a pretty interesting project, and I've tried to done the best I could. Let's see how it works. Okay, so this is how my prototype looks. It's a basic box that I've put together with my sensors coming out and my servo, just so that it can be seen properly. And then this is my DC motor. I also tried using this one to actually show the wheel moving, but this gear ratio is not making my DC motor is not getting enough power to make the tire move. But if it were, I would have used this DC motor. um, so this is how the system looks. This is my ultrasonic sensor, which senses the objects in front of it. This senses for humans the DST-11, and the servo directs the angle using gesture control. um, Next I have I'll show the circuit. So yep, this is the power source module that provides additional 9 volt of power to my circuit. Then I have a red LED that indicates the person, which is connected by a 220 ohm resistor to ground and to pin number 7. Then I have my ultrasonic sensor, which has 4 pins. One is connected to ground, one to 5 volt, and one goes to the trick goes to number 5, and the eco goes to number 8. I have my potentiometer that is connected to A0, ground, and 5 volt. And then I have my then I have my DC motor driver. So it is the L293D driver, wherein I have enable the motor enable 1 and 2 connected to pin 9. Then I have input 1 connected to 10, and I have input 2, that is the 7th pin on the connected to pin number 11. 4 pins go to ground. Pin number 16 goes to 5 volt, and pin number 8 also goes to 5 volt. So that's how my L293D is connected, which is and then I have pin number 3 and 6 that go to my DC motor. So that is how my uh, uh, components are connected. Then I have my servo motor that is connected to pin number which pin is that? Yeah, it's connected to pin number 6, 6 ground and 5 volts. And my DHT11 that is connected to, and the signal is connected to pin number 4. So that is how my entire circuit is connected. So let me explain how the control works. For my servo motor, I have my hand here that has six aspects, six 3x2 grid. If I place it in the center, the motor will remain in 90 degree. If I turn it to the right, it will go to the right. So I have a grid of 3x2 for this. That is how it controls. If it's on the upper side, it goes forward, and if it's on the lower side, it goes backward. The motor moves backward. Okay, so this is my hand, and it's in the center, so it's saying top center. If I turn it to the right, it will slowly take it, like turn the to the right. It is center. If I take it to the left, it will take it to the other side. And if I take it down, the motor starts moving backward. And if I take it to left, it goes left. And if I take it to the right, my servo goes right. And this is my motor that is running in the backwards direction. And if I go forward, it changes its direction. Backward, change its direction. Forward, change its direction. And so my sensors are running right now, and if I place my hand closer than 5 centimeter to the ultrasonic center, it says obstacle detected 2. And if I touch my humidity sensor right now, yep, it's slowly increasing the humidity. My threshold is 60, so yep, and it says survivor found, and my LED turns on. So that is how my project is running. The DC motor couldn't drive power, so I had to stop making it run, but I've also provided the 9-volt power source module. So that is how my entire project is working. Yep. Okay, so next we go through the code. The cell one is in which we install all the Python libraries using pip. These are OpenCV for camera, image processing, media pipe, telemetrics, and PTTS3X for the speech. Then in cell 2 we import all of them. So we import all of these libraries. It's pretty common. Then we have cell number 3, where we download media pipe for the hand detection model. Then we have cell number 4, which actually declares all the pin configuration. So we have all the pins mentioned over here for everything, along with starting up the Arduino. And we connect the Arduino to telemetrics and configure each pin mode. In cell number 5, we have okay, yeah, this is cell number 5. So this cell initiates all the variables such as servo angle, motor detection, obstacle detection, flag, temperature, humidity, and it also starts the background speech thread. The background speech logic works like this. A queue object acts as a message buffer, and the main loop calls speak async, which pulls the text into the queue without waiting. The background thread runs in an infinite loop, pulling messages out one at a time and speaking them using the PyTTSX3. Because it runs in a separate thread, the camera never freezes while the audio is playing. Then we have cell number 6. So cell number 6 is all the motor helpers, and sensor callbacks. So for example, the motor forward and backward, right, high and low for the direction. So IN1 high and IN2 low means that it's forward, and IN1 low and IN2 high means it's reverse current. So the motor is going backwards, and the PWM value on the using the potentiometer from 0 to 225 helps control speed. Motor stops just brings the values to 0. And we have update motor, which function it first checks the obstacle, and if true, then it calls motor stop. Otherwise it applies a fixed speed of 180, and actually, yeah, it applies speed and helps the motor run. Then we have a sonar callback. So this function is registered with telemetrics, and it fires automatically in the background. It thread for ultrasonic and completes a measurement. It reads the distance from the data index to, and then compares it against the 5 centimeters threshold. So if the object is closer than 5 centimeters, obstacle detected is set to true, and the the cooldown audio is queued. There is a 5-second window that we have provided, so it prevents the same alert more and more times. Then we have the DHT callback. The DHT callback fires every 2 seconds. It provides the humidity data and the temperature data index 4 and 5, and if either value crosses the threshold of 25 or 60, human vicinity is set to true, and the LED turns on, and survivor found is queued for the speech. This is for face recognition. So we have all the images of my image loaded in the folder called as images. Um, so it actually like trains on it, and then if it authorizes, so if it detects my face, then it allows like for it to run. Otherwise it returns the value of unauthorized user. Then we have media pipe and line marker. So we load the video mode, which requires a timestamp with every frame for temporal consistency. uh, The confidence thresholds are set to 60% for detection, presence, and tracking. This creates a landmarker object that is. Then we have cell 8. This helps with the servo and gesture helpers. So we have the camera, like the area divided, screen divided into 6 zones. uh, Left, right, and center are the 3 columns, and the control servo takes these as the inputs. So and accordingly it defines the target angle. So left, it maps to 30 degrees, center it maps to 90 degrees, and right it maps to 150 degrees. um, Instead of jumping to the target instantly, it applies an exponential smoothing, so it goes smoother. So that I have provided it as 0.3. Initially I made it 0.1, but because it was becoming heavier, I made it 0.3 so that it becomes better. Then this means that each frame the servo moves 30% of the remaining distance. Then I have control motor direction. So this one, yep. It simply sets the global motor direction to forward if the hand is in the top zone, or backward if it is in the bottom zone. Then I have the main camera loop. So while the while loop runs continuously, and does the following iterations. First, a frame is captured from the webcam and flipped horizontally so the gestures feel natural, and converted from BGR to RGB for media pipe. Um, After that, a timestamp in milliseconds is calculated for loop time start. This is required by media pipe, and it uses timestamps to smooth the landmark tracking across frames. The frame is passed in the landmarker detect for video method. Um, if a landmark are found, we take the first detected hand. So the palm center, instead of fingertip, which moves a lot, we take the average of x and y coordinates of the three stable points. The wrist at index 0, the index finger knuckle at 5, and the pinky knuckle at index 17. This gives a stable center of mass for the palm and doesn't just jump around the finger movements. Zone detection. So uh, no, the normalized S coordinate, which goes from 0 on the left to 1 on the right, is divided into three columns. Below 0.33 is left, between 0.33 to 0.66 is center, and above 0.66 is the right. And the y coordinate is split in half and half. So below 0.5 is top, meaning forward, and above 0.5 is bottom, which means backward. So the gesture hardware control servo is called, and with column to move the servo smoothly, and control motor direction to direct the uh, direction of the motor. Update motor applies speed and direction to the motor. The HUD then draws the grid lines, and then all the overlays, all live data, zone, servo angle, motor detection, speed, object status, temperature, humidity, using CV dot put text are fixed at positions on the frame. The text color changes for to red for critical states like obstacle detected or survivor found. Pressing Q breaks the loop, and finally block runs. Motor stops, servo centers, Arduino shuts down, and camera releases. All windows are closed. So that is how this entire um, code is running. Hi, so I wanted to add a note in the end of this course. So, as we come to the end, it's been a long journey. I started with not knowing anything about Arduino, not knowing anything about coding, to actually learning how every pin works in Arduino, how different components work. So, I came from a zero background to a point where I could at least make my own circuit. Write the basic code for it, understand what kind of functions are needed for what kind of circuits activities. So I learned a lot, starting with like the basic blink LED tutorial to actually making this final project. It's been a long journey, and I'm thankful for everything. Thank you.